Hello friends, I'm Konstantin. Today I will give a talk about Pheix content management system beta release. But before I would like to introduce myself. I'm dealing with the real-time programming, multi-threading, low-level development, stuff like drivers, operating system, components and whatever. Also I'm remotely working as Perl backend developer focusing on online payments. I'm contributing and maintaining a few Raku modules like Etherscan, LZV Road to Riot and eventually Pheix. Previously I have taken part in a few workshops, Perl workshop and conferences. I hope some of you remember me at German Perl and Raku workshop 2020 that what happened in Erlangen last spring. Well, that's me. Let's start with my talk. Today I will speak about the Pheix content management system. It's beta released. Pheix is artistic license compliant Raku language-driven content management system with data storing on Ethereum blockchain. It's lightweight, fast, and scalable. I started the work on Pheix about 3 years ago. In 2018, it has begun as a challenge. My plan was to make a simple Raku port of Perl Pheix CMS. Step by step, the road was changing. Some features were gone, some, like a blockchain support, were added, and I have passed away from early alpha version to official public beta release. The modern Pheix is the content management system for Web 3.0 oriented projects. The system basics are decentralized modules, security, and storing the content in different target storages, regular databases, private and public Ethereum blockchain networks. The private beta was released in last June. It has shown that Pheix had a few generic issues, and the most important one is about content render time. At private beta, we are rendering content on server side with template mustache modular in about 3 seconds. It was really slow and really bad. To speed it up, the next improvements were suggested. First of all, we decided to try fast CGI. The second is about careful object management. We need to make object reusable at least and try to load all static data and other things on the first run. I mean configs, templates and whatever. The next is the client-side content rendering. We try to use Riot JavaScript components library for rendering content with JavaScript in browser. It should be based on REST API, of course. Finally, we needed public Ethereum test networks integration. Yes, it works with private proof of authority networks, and basically there were no latencies and other specific to real-world things. But we were very interested in test our system, our application in real test networks. So the full list of suggestions for public beta release could be reached via this link. Okay, as it was suggested, we did a few changes at initial system design. We'll discuss it later in details, but now I would like to put some summary for public beta features. Now I just say that we have tried to combine legacy and headless architectures, and I suppose the term like a hybrid architecture. Templating engine improvements, we have migrated from template mustache module to patched HTML template module. Code refactoring and efficient object management. I have rewrote most of the classes, most of the Pheix classes, obviously constructors, setters, and getters. We integrated support for a public Görli Testnet. By the way, previously supported private local proof of authority networks also works fine. Scalability and external modules. Now we have a short specification how to add new modules, and also we have added a simple add-on that serves simple block, homepage manager as I say. With this link, you can trace all public beta release issues and tickets in our official repository. Okay, looking back, I see that in the beginning of 2020, the alpha version was released. It was some kind of prototype with the basic CMS functions like a presentation layer, sitemaps, roads, and very early blockchain support. In the middle of 2020, the private beta I supports more or less stable version for private testing was released. Regarding this milestone, I have performed a talk about creating secure decentralized content management system on Ethereum blockchain with Raku. It was given at the Perl conference in the cloud. And on the 19th February of this year, Pheix was officially public beta released. The new milestone is passed, and I have already a few projects driven by Pheix in production. Latest one was presented in this February at FOSDEM 2021. Check out the talk programming digital audio server backend with Raku. Traditionally, the beta version is published once all scheduled major features have been implemented and released. I suppose several beta versions will be made available during this phase. As with any program beta release, now you have early access to new features and able to test them and give your feedback. It's very valuable at these final steps of the development, and we are considering your feedback as a state of new improvements in further version, in the final version. Be the first to try upcoming Pheix content management system features. By reporting any bugs you encounter using this beta release, you will actually help us to catch the bugs and go through some curious and unsuspected cases. That means you are likely to try Pheix as less stable but closer to final version. The major Pheix beta release improvements are related to content rendering performance, blockchain support, and overall look. Okay, let's look at previously released private beta. It has supported private Ethereum proof of authority networks, has quite nice test coverage, and has representation layer basic implementation. We have published some sample proof of authority network setup and instructions so everyone could run own test network or get access to our private network for testing. But private beta was too slow. Average content render time was about 3 seconds. Private beta version wasn't compatible with public Ethereum networks. Public beta was unscalable. No any flexible tools to add new features. And finally, private beta has legacy CMS design. Let's consider that CMS design as well. As you see on this picture, basically we have 3 types of CMSs: legacy, decoupled, and headless. One of the basic goals of the public beta was to make Pheix truly headless. Eventually, now I can say that Pheix is based on hybrid CMS concepts. On one hand, we use legacy CMS approach for page rendering, page template rendering. But on other, we use REST API, JSON REST API for page content rendering, and this case of headless CMS. Okay, at main template render we works as old school CMS. Template is embedded and is pushed to the output as HTML. But this template has mandatory content block with Ajax, and here we become headless. Content is retrieved via JSON REST API. The general benefit of headless architecture is that you can make your access much more secure with presentation and administration layers on different Ethereum nodes. Yeah, it's great because your system, your application becomes decentralized. A templating engine basically provides tools for effective metadata interpolation inside static files. At web application runtime, the engine parses and replaces variables with actual content values. Finally, client gets an HTML page generated from a template where all metadata, I mean variables, statements, expressions, has been processed. Raku ecosystem has a few modern templating engines. I mean template mojo, template mustache, template 6, template classic, template toolkit, and of course old one HTML template. Well, template mustache was chosen for a private beta. I have done the humble research where template mustache, template 6 and HTML template modules were compared. Also, there were a few tricky techniques with the grammars, regular expressions, and XML trees. There were a few techniques for performance boosting we considered and explained. The results were published at Raku Advent Calendar blog, and the link for this article is given on this slide. So if the web application works as a classic CGI instance, no caching, no available workers, no proxies, everything run is from the sketch, the request will be rendering at least 2 seconds. I don't consider network latencies, duty cycle, templating, or service resource throttling. Actually, this time maybe more than 10 seconds. And in the case of a few Perl clients case. And this time is absolutely bad. After we have optimized our templating engine, we have got about 100 times boost. And there were no any subhuman techniques, no client-side rendering, no another magic, just we have rewrite our existing Raku code. And I suppose it's very impressive. Private beta use legacy CGI approach. It means on every request we start Pheix instant process, create and initialize all objects, prepare everything for the usual run, reading config files, try blockchain nodes, Pheix templates, and whatever. When we use fast CGI, we reuse previously started instance of our application. Migration to fast CGI requires much more strict objects and data management, implementation of a duty cycle, and more accurate exceptions error handling. How do we need to serve the reusable objects or data? All static objects should be created once the application started. All static data like configuration or templates should be retrieved once the application started too. All static objects should be reusable. If they are used in different classes, we should create copies, avoid origin object modification and destruction. And finally, static objects and static data should be accessible from other classes. So we should implement getters at least for this case. And here's the results. Fast CGI make it works as a regular CGI instance for the first run, and as you see we have about 10 seconds start time. But every next run is much more cheaper. At least 500 milliseconds on low resource servers. I make this benchmark on the Core 2 Duo, 2 GHz with 8 GB RAM. Here is a note for the last image, and as you see there are a few turtle requests, slow requests in the background. First one is a big bro. It's a statistic grab request. It's slow because it's used input-output, works with disk, does some data processing, and there is no any optimization in this area. So here we have some things to optimize. And the second one is a post API. This is capture retrieving request, also slow because of input-output, I mean disk usage, and some explicit image processing work. So it's just an example how to generate capture on the fly. As I said before, Pheix is based on hybrid CMS concept, and like headless CMS, we use REST API for page content rendering. The template has mandatory content block with Ajax that is used for retrieving the content via JSON REST API. The JSON sample is presented here, on this slide I mean. We get the response with the content template and the key value pairs as a variables where should to substitute in the template. The substitution is automated with Riot JavaScript components library as client-side, at client-side. Its API is heavily inspired by Vue.js, but it contains just a bare minimum to build a modern front-end project. It's intuitive to use and it weighs almost nothing. See Riot JS details via the top link on this slide. Also, you can try Pheix API debugger. The link was the previous slide also, as you see in the middle. To check how it works, what are the requests and what are the responses. You can send them a request and get a sample response. This is response. On this slide we see the response. We see a response with JSON data. We got this content template as a component and the variables as typarams collections. These variables we have to substitute in a content template. There is additional metadata like render timings and statuses. Component is based via base 64, and this at this slide you see the fake component, but at real response the data in this the value of this key is quite big. Obviously it depends on the content. For example, for Pheix or index page we have something like 100 kilobytes, so it's quite heavy in base 64. On this slide you see the link to the Planker at the top. Planker is the tool to prototype, experiment, share and debug code snippets on the web platform. There you can see how client-side rendering works, look around, change something and get the feedback. Also you can just copy-paste the component and typarams collection variables from response that was given on the previous slides and see how it will be finally rendered in your browser. So it's handy utility as an additional thing to API debugger. Private beta also has support for private Ethereum proof of authority networks. We have published sample proof of authority network setup and instructions so everyone could run own test network and get access to our private network for testings. The next step is to integrate support of public networks. We start with Görli Testnet. This is the first proof of authority cross-client testnet syncing parity Ethereum, Gets, Nevermind, Hyperledger Beso and Ethereum JS. We use Infura.io service as a gateway to Görli Testnet. The Infura API suite provides instant access over HTTPS and WebSockets. Please look at this Pheix config snippet port section. The original Infura access token, obviously masked as an Infura API token, is pushed as a part of URL port. Yep, it's some kind of dirty hack, but it works and of course should be fixed in the future. As soon as the CMS is correctly configured, you can commit the transactions to the Ethereum network, to the public Ethereum network. On previous slide, we have the config where the smart contract deployment transaction was set, and C D4761354 whatever big hash. And now you can browse these transactions via Etherscan EO service by its value, but transaction hash, I mean. On this slide, you see the list of transactions with Pheix org content. Of course, smart contracts should be deployed before you start using CMS. The simplest way to deploy is to use MetaMask servers, because functionality of how the data is stored in blockchain and how the data is retrieving from blockchain is inside the smart contract. So if the smart contract not deployed to network, CMS will not work properly. Here's a screenshot of the first of the records of one of the records from Pheix org block. I call it pinned. So this content is entirely stored on blockchain. Every time you browse this page, the data is retrieved from Görli Testnet. You can check it out and feel some latency while you are browsing this page. And we have the transaction number. You can check the transaction started with 97E92AB for this record. And via Etherscan EO, you can grab the details, and I share them on this slide. You see a lot of metadata like block number, transaction fee, and whatever. But really interesting thing is that you can see the page content as decoded transaction input data. Also, you can estimate transaction cost in mainnet by gas usage value. Of course, it's very approximate. Okay, how does Pheix work with add-ons? First point is add-ons are regular Raku modules. And the second point, add-ons have a strict development guidelines. As I said before, Pheix is based on hybrid CMS concept. We use both legacy CMS approach for common page templating and JSON REST API headless CMS approach for page content rendering. So it should be kept in mind during module implementation, because some modular methods are CMS independent. I mean, you can implement there as you want. But on the other side, we have a few CMS dependent methods, and they used by CMS at least. So we need to we need to use specific names, and we should prototype them in a special manner. Sampled on modular source code is available via the given link. More info about Addons development you can find on Pheix wiki pages. Let's consider the real case of the Pheix add-on module. This is digital audio server add-on. More details about this software were given at FOSDEM 2021 conference. Well, the talk about this is available at Pheix.org. Also, the link will be published in the credit section of this talk. Well, the basic config suppose route setup. Digital audio server uses at least 3 routes. As you see on the slide, we have file upload page, should support both get and post methods. File index, just a page with the uploaded files list. And file details, actual frequency analyzer, result page with spectrogram and plots. It's a digital sound related thing, digital sound processing related thing, but the main things, the main details of the main information, the generic information of digital audio service is shown on this page. As you see, the route is quite complicated. We use a regular expression in it. And for support such routes, we have used router write module as a primary router in Pheix CMS. It has a good performance and provides powerful tools for route annotations. Check module wiki for details, and a link to module wiki is also attached to the slide. As you see, routes are configurable. We store routes in JSON configuration file. Here is a sample with previously considered routes. We see 3 entries. Every route has own path and own handlers. Default handler for page and API handler for content. Default handler renders the page from template with Ajax code. It performs JSON request for content, and this request is processed by API route and API handler as well. So as you see, to render the page, we need at least 2 routes, one for entire page and one for content. Please keep in mind that doesUpload method for doesUpload route path should support both get and post methods. In other words, on get, it just outputs the upload form where doesUpload API method. On the post, it should perform the upload itself. To integrate any features to Pheix, you should implement them. Cover them with the route-related API calls and wrap into new class. New class should also have a few mandatory methods required by Pheix. As I said above, we have a few specific specific methods with specific names that in your class, in your addon, and these methods will be used by Pheix to integrate your module in own structure, in whole architecture. For example, you need init.json config method. A few slides ago, I have spoken about careful data and object management. Every addon has own configuration file, and to speed up the application performance, we're loading configs at the first run. This method is used by Pheix at the initial step, and at this step when the system is scanning all installed add-ons. You need to have a prototype of get method. This method is used to have access to generic application controller object from your addon. Pheix pushes it to the addon class getter, and we do not create addon objects on a duty cycle to prevent latency, so this is a way how to give addon details about its controller. We have get class and get name methods. It's just helpers. They return some major info about addon. We have get sm. This method should return sitemap for addon. It's just a plain XML with the routes pages that addon serves. It's a very standard data. And finally, you need to include fill SEO data method in your class. It's search engine optimization related method. It should return title and meta tags values for given page route or road. It's a very interesting thing. We implement night mode skin. It's a trend to support now. It's a trend to support the night and day modes on your website. And I have added this night skin just for practical purposes. I love to work at night, and white side skin was very contrast to me, so I got the idea. Okay, let's add the night one. Yes, now my night work becomes much more comfortable with the night skin. This is a day skin, just a contrast text on the white background, and here is night skin. It's very great to use it while you're working when it's dark outside. Okay, beta is released, and what's next? I'm working for full roadmap and have already announced Pheix content management system release candidate number 1. They will be the basic breaking changes. First, it's a migration from Elsevier Evolunet compression module to compressed BZ2. Also, I consider a case to make this feature configurable. Just set the required algorithm in global config and go forward. This approach is perfect for further scaling. The next important update is related to Pheix distributive. Now we have all-in-one distro with everything we need to go live, and I suppose it's not good for accessibility and compatibility. For example, some of existed projects somewhere could be partially integrated with a Pheix, so it should be used as it could be used as a dependency or external module. And in this case, our current distribution has a lot of unused stuff. And the third breaking change is user interface will be extended with a naive implementation of administration layer. Actually, the big deal to add this layer as a Ethereum node interface. I will consider it below. And you can check many RC1 issues or tickets with the link in the bottom of the page, of the slide. Okay, I have done the compression efficiency investigation and finally compared Elsevier Evolunet and compressed BZip2. The last one provides triple better compression rate. Triple better compression rate, I would like to repeat. It's great boost for blockchain performance and overall application speed, I think. To release this change, we need to update smart contract. I mean migration from string to bytes, because now we are storing on blockchain side, we are storing all texts in string structure. Yeah. Also, we need to create sample datasets and update unit tests. It's about wrapping transaction with compression functions at least. Because if we use a few different compression types, compression algorithms, we need to create functions that commits transactions to blockchain universal. So now we have prepared the data to commit to blockchain and push it to transaction function as an argument. So I'm supposed to create a new function with a new wrapper function that will be check what method, what algorithm is used to compression now, and perform the compression inside this function and commit data as an argument to transaction function as well. We need to add handy tools for data inspection, JavaScript module with a CRUD function, for example, because now we see the strings in blockchain. We can retrieve the data from blockchain and see, okay, this string, I see hello world. Yeah, it should be hello world. But now after the migration, we will have compressed data. So we need some tools and utilities to retrieve compressed data, uncompress it, and see, okay, we want hello world, and here is some compression bytes. Some bytes, that means that the data is compressed. We need to uncompress them and compare with the initial string. The same thing we need to create on Raku side, so I think we need to add script for BZ2 compressed data inspection. I have created, as you see on the slide, we have a link in the bottom, and I have created a separate workflow for these changes. Please check out this link, and there is the diagram with the steps how to implement it. The next thing is a distributive update. Now Pheix includes everything you need for deployment. I mean generic module, startup script, web resource, configuration files, and whatever. And as you see at the screenshot, we have hooks, for example, hooks and www folders also in the distribution. They are actually unused when you are installing Pheix via Zeph or want to use it as a dependency or external module. So I'm planning to split up a distro to Pheix
Raku module as a generic entity and to Pheix deployment stuff as a dependency or add-on. I'm not sure how it will be in a final look, but I think, of course, Raku module, we know it will be in a Raku ecosystem, and the deployment stuff, I think it could be a separate repository that you will clone to your deployment environment or somewhere where you are using Pheix or whatever. So this is the point of discussion as well. Pheix release candidate 1, user interface, will be extended with a naive implementation of administration layer. Actually, the big deal is to add this layer as an Ethereum node interface. In this case, we will get such node features like authorization or access level model out of the box. So we don't need to implement anything on Pheix side. It will be taken from Ethereum node model. On the other hand, this idea requires available private Ethereum node or available. We should have working Ethereum node on the same server or in the same network where your content management system works. If you use some low cost hostings or cheap hostings, I think it's a problem for you because it's not easy to run the node on the cheap hosting where you have limited resources. I think in some cases it's impossible. And if you run the node available via internet, it's a security risk. So I think here is the problem. So the other solution is to implement the transaction signing at Ethereum module. In this case, you will just have a private key and you will sign any of your transactions and commit them to any public node like Infura IO service or, for example, Prism Labs or whatever. It's a little bit tricky, and by the way, it's still also a point of discussion, like a distributive problem we discussed a few slides on the previous slide. Also, I'm permanently working on code cleaning and refactoring there, and release candidate number 1 will be accumulate this kind of updates as well. Okay, we are very close to the end, and currently I will speak about what projects are in production. Driven by Pheix. Currently, we have a few projects. The first one is a Pheix.org website. It's just a little blog with a few posts on blockchain. Not serious, just a landing page. The next one, and I think it's much more interesting, is a digital audio server. It's a backend driven by Pheix, and the details were discussed at Perl Development Room at FOSDEM 2021. There are a few interesting tricks and hacks related to digital signal processing, native calls from Raku application, and Pheix integration as well. And the third project I should mention about is Ethelia. This service provides transparent and secure JSON REST API for web application or any web projects to store any data on Ethereum blockchain, no matter private or public networks, no matter what data, binary, text, or whatever. And you can check early alpha draft of Ethelia server specification via the link in the bottom of the slide. Okay, I would like to invite you to Pheix development process. Yeah, it's traditional thing in the end of my talks. On this slide, I publish the links. All are available, and as you see, there are a few projects, so you can try any of them if you find it interesting. Forks, pull requests, code reviews are very welcome. Also, if you like any ideas from this talk, any concepts from this talk, let's get in touch. Any discussions, any suggestions, also highly recommended, also very welcome. And of course, if you could help me to keep this work on, please donate. That's all, the end of my talk. I would like to thank German Perl and Raku folks, GPV 2021 organizers, and I'm proud to perform this talk, and I'm happy to meet you all again there, virtually. Hope we will meet you face to face next year in Leipzig. So thank you. Please go on if you have any questions.